What's happening, dogs? Mr. Allen here with a little video on writing functions given a table of values. Now, we'll see what kind of functions they are. Are they linear? Are they quadratic? Exponential? I don't know. Let's take a look. So I've got a consistency here in my x's. It's always going up by 1. Cool. And then my f of x, my y values, my outputs, I'm going down by 3, down by 3, down by 3. This is a linear function. So f of x is going to be a linear function. All right, now, two things I need for a linear function. I need my slope. I need my y-intercept, okay? So my slope is my rise or my run, or my change in y over change in x. If you can see it here, awesome. If you need to do a little work, that's cool too. I'll show you using a little work. So my slope, which we notate with an M, fancy cursive M, right, is going to be my rise, my change in my y. I can pick any two values. How about 10 minus 7? 10 minus 7 over, then I got to take my corresponding x's, negative 3 minus negative 2. Those become positive. I'm going to get 3 over negative 1. So negative 3 is my slope. And as we can see, as my x values go up by 1, my y values go down by 3. That makes sense that it's negative 3 for the slope. You could have seen that from the table. You could work it out like this. I want to show you guys both ways to do that. That's dope. All right, so I got my slope. How do I get my y-intercept? Well, if you look right here, 0, 1 is where it's crossing the y-axis. So this is my y-intercept. We don't always get that from every table, but I got it here, so why not use it, save a little time, right? So I'm going to have f of x equals, my slope is negative 3, x plus 1. And if you're not sure if this is correct, you want to double check yourself before you perhaps wreck yourself, right? I can plug these in. If I plug in negative 1, I'm going to get negative 3 times negative 1 is positive 3 plus 1 is 4. If I plug in negative 2, I get negative 3 times negative 2. It's positive 6 plus 1 is 7. Then I get 9 plus 1 is 10. We Gucci, man. We Gucci on this one right here. All right. How about this one? So let's see here. I'm going up by 1 from all my x's. Awesome. I'm going up by 2 for all my y's. So our slope should be rise is 2 or change in y is 2 over change in x is 1. 2 over 1 is 2. But let's write it out just in case you're like, that was a lot. I didn't follow all that. All right. We can pick any two values here. Okay. I'll do, how about 2 minus 4. So 2 minus 4. Then I just got to do the same for my x's, 4 minus 5. I'm going to get negative 2 over negative 1, which is positive 2 as we already stated, right? So my slope is positive 2. All right. So how about my y-intercept? I see a 0 here. Wait, that's an x-intercept though, not my y-intercept. So check this out. We may have to do a little bit more work. What I'm going to do here is I'm going to write out just y equals mx plus b. And what we're going to do is we're going to plug in an x and a y value. It doesn't matter which one you pick. I'll do 4, 2. So 2 is going to go in for y. 2 is my slope, which we just found. My x value there is 4 plus b. So that's going to be 8. So we got 2 equals 8 plus b. I think I'm going to run out of room here. But if we subtract 8, I'm going to get b equals negative 6. So that's going to be my y-intercept. If I subtract 8 on both sides, I'm going to get b equals negative 6. Now I can write my g of x equals 2x minus 6. I just got my y-intercept. There we go. We wrote ourselves a function using two different tables there. Each, this was a little easier, gave us our y-intercept, but hey, we handled it. It was all good. Totally dope. If you ask me, I think that was awesome, man. All right. There we go, guys. Hope you enjoyed that. I thoroughly enjoyed that, and awesome. You guys have yourselves a great day. See ya.